Now, both of you can see my screen. Then at least you all must give me thumbs up lah. When I ask you question, you have to answer lah.
Okay.
Okay. So I will, because I can't see you, then I'll be asking you a lot of questions. Is it okay? Thumbs up. Okay. So Jocelyn, same thing. You have been doing the thumbs up just now. So let's practice that. Okay, so quickly go through. I know, Jocelyn, you already covered this part, right? And then you are even on the conversion, etc. Seems like your school is a lot faster. Sherman, what topic are you on now?
Still environment.
Still environment?
Yeah.
Oh, okay, can. Never mind. Okay, anyway, this topic will be taught sooner or later. So quickly go through, okay, key concepts. You need to know forces can change the state of rest or motion of a body. Okay, you can change the size and or shape of a body, bring about turning effect in objects, exert pressure on objects. Okay, so you need to identify some examples of contact forces and non-contact forces, predict their effects on an object. Then solve problems of objects in motion, okay, using the concept of speed. So some questions, okay, can actually link to speed also. Then make measurements of mass and force using their respective SI units. You still remember SI units, right? Okay, last year you probably learned already. Compare mass and weight, then pressure. Okay, relate pressure to force and area using appropriate everyday examples. Investigate pressure using its formula. Jocelyn, have you done pressure?
Yes.
Okay. So this is actually the photo, I think, of Turkey earthquake, the very recent one, right? Okay, so earthquakes can happen in many parts of the world. We are lucky. Okay, Singapore, we don't experience earthquake, at right where we are. Okay, but we feel the effects of earthquake from other places. Okay, for example, okay, when Indonesia had the earthquake, okay, some parts of Singapore actually felt the vibration, right? And that is like such a distance away. Okay, the earthquake occurred, but in Singapore, certain parts could feel it. Right, so earthquakes is like the natural force. Okay, it's from nature. All right, forces from nature. We cannot control it, but scientists have been able to predict when it will happen. They can also measure the magnitude, how strong it is. Then they know how to even, make prediction, how much will be affected. So the impact of the earthquake can also be shared to the world. All right, this particular one seems to be pretty serious. Okay, we have also, I also know of people who have friends there and then did not survive during this earthquake. Yeah, so my friends, they are very sad. Okay. Tsunami. Okay, this is really how tsunami can look like. This is actually, I think, some drawings by somebody. It's an illustration, not the real thing. So tsunami is actually a series of large ocean waves, often caused by powerful earthquake under the ocean. Okay, so earthquake not just lead to the problem like this, okay, on land, but at sea, it can lead to a rise in this ocean wave. So they actually go very high up and then go towards the land. So tsunami has already occurred in many parts of the world, okay? And then if you are not familiar with tsunami, maybe after the lesson, you can go and Google a little. Quite scary, the effects. I've watched a movie which was talking about tsunami, and I was quite affected by what happened to the people. Okay, people who survived a tsunami, all right, and then people who didn't survive, like they show quite clearly in the movie. That was quite impactful. Now, volcanoes, because of the magma that exists underneath. So if you can see the picture here, okay, the magma, right, it exerts a force on the Earth's crust. Okay, if let's say the pressure here gets built up, right, okay, it will be forced out. And that is where you have the volcanic eruption. All these are the lava, very, very scary. Okay. Typhoon, powerful storm. Okay, quite different from tsunami. This is actually this is not like the huge wave, but there are a lot of strong wind and a lot of rain. So can you see all the trees? Okay, because of the strong wind blowing in one direction. Okay, so this can happen. So it actually destroys properties. Okay, it causes floods also. So when we talk about forces, okay, we are actually talking about pushing or pulling, exerting a force. Effects of forces, you learned this in primary school. All right, I'm not going to go through each of them, but you do know what I mean here. Okay, and then how do you measure forces? At your level, you need to know, okay, the instrument to measure forces are the force meters, for example, the spring balances. Have you done this in the science lab, Jocelyn?
Yes.
Do you like it?
I don't really see much.
Okay. You find it not exciting enough, right?
Yeah.
I know what you mean. Okay. Primary school science seems to be a lot more interesting lah, compared to secondary school. Okay, friction, you need to know, okay, the forces that we talk about are still the common ones like you learn in primary school. Friction, okay, so we call it frictional force. Then we have gravitational force, right? What is the next one that you learn? Frictional force, gravitational force. Sherman, can remember anything you learned in primary school?
Forces.
Yeah. We learn forces in primary school. You recall? You do experiment also. Okay. So on the fridge, what do you have? Do you have a lot of things placed there?
Magnets.
Magnet. So magnetic force is another one, right? Okay, there's one last one. Okay, there's another last one. In your pen, especially the pen that you can click. What's inside?
Spring.
Spring. So we also have another force that is called elastic spring force. Yes, Jocelyn, correct. Thank you. Okay, not just elastic spring force. Basically, we can just call it elastic force because why? I can't even find a rubber band now. I used to have a lot of rubber bands on my table. Okay, so rubber bands also have elastic force, right? Okay, so these are the forces you need to know. Then come back to friction. Friction acts whenever one surface rubs against another surface. It can be solid, liquid, or even gases. Friction causes surfaces to heat up. It always opposes the motion. Okay, so that's why when you have a very rough surface, okay, you try to roll a ball, not so easy to roll it. But let's say the surface is extremely smooth, like the bowling alleys, very smooth surface, right? You see how the bowling ball actually rolls so nicely? You try to roll the bowling ball on the car park surface, so rough, right? It cannot roll very well and you will spoil the ball also. Okay, so machines, we reduce friction by actually using ball bearings. Okay, and then we can also apply lubricants, okay, like grease and oil, wax as well. Streamlining, example, shape of an aircraft, the shape of a sports car. Sports car are very streamlined. If you like sports car, okay, you would know that, okay, the sports car looks so streamlined, so classy, not like the usual kind of car you see on the road. It is very, very streamlined. You can see that it's not like box shape. Box shape kind of car is like the olden types. Okay. So forces, we can also classify as contact forces, non-contact forces. Non-contact forces are like magnets. You don't have to let them come into contact yet. You will feel the pull or the push. Yes. Gravity is always a pull from the center of the earth. Okay. It can be the center of the moon if we are talking about the moon okay, exerting the gravity. Contact forces must be things that are in contact. Okay, elastic force also got to be in contact. Magnetism, okay, so you already know this is non-contact force. Like poles repel, unlike poles attract. So for magnetism, okay, it can either be a push or a pull. Gravity is always a pull. Can y'all get this? Must remember. It's a non-contact force, but it only involves pulling, attraction. It exists between any two objects with mass. Differences between mass and weight. Okay, remember, weight is a measure of the force of gravity exerted on an object. Okay, the heavier an object, the greater the force acting on it. Unit of weight, Newton. So these are the differences. You should know by now. Okay, because in primary school, we also do this. Okay, measurement of the amount of matter in an object. This is actually about the force of gravity exerted on the object. And then their SI unit also different. This is kg, this is in Newton. Okay, so pressure, Jocelyn did this already. Pressure is actually a measure of the amount of force acting on a unit area. Okay, the SI unit is Pascal. Okay, pressure in liquid and gases. Okay, this one I will demonstrate to you certain experiment. Okay, I'll show you videos next lesson. So today we are not focused on pressure. We are still going to be covering the other parts of forces. Okay, and for gases, right, the higher you go, the lower the air pressure. These are just some facts. Okay, and then examples, right? So all these, I will try to find all the examples, but in the form of video for you to see. Okay. So let's say when you're drinking, you know, the packet drinks, right? Packet drinks in the paper form. When you are sucking on the straw, okay, how does it feel like? Okay, and then what about those suction cup on the wall? So all these, it will be easier for you if you can see, okay, the actual video. Then you can relate better. Now, very quickly, I finished the summary. So now we will go on to a quick video first. Then we will do the worksheet. Let me know if you can hear this, you put a thumbs up.
In the first part, we saw that force is not just a human pushing or pulling an object. A force is a push or pull upon an object resulting from its interaction with another object. There are two things we will cover in this video: types of forces and the effects of forces. For simplicity, we can classify forces into two types: contact forces and non-contact forces. Contact forces are just what they sound like: forces that result from the interaction of two objects in contact with each other. Are there any contact forces you know of? Of course you know a few. What happens when you softly kick the ball which is lying on the ground? You applied a force on the ball and there was contact. Applied force is one of the contact forces. Next, there is a force of friction which brings the ball to a halt. As the ball is in contact with the ground, the frictional force is also a contact force. Don't you think there was some air resistance? Yes, air resistance too is a contact force. The normal force, which is applying force in the upward direction, is a contact force as well. These were some of the contact forces we know of, but these are not the only ones. Can you think of any non-contact force? What happens when the ball is in the air? It will fall down, right? What pulls the ball down? Yes, it's the gravitational pull which is trying to pull the ball towards the center of the earth. This pull happens even if the object is not in physical contact with the earth. The gravitational force is an example of a non-contact force. Other examples of non-contact forces are electrical and magnetic forces.